Hello everyone, the purpose of this video is to showcase how you can leverage the Infrastructure Manager Action Pack from Nolio Release Automation to deploy applications to any cloud provider of your choice. As we all know, the Infrastructure Manager Action Pack helps in provisioning of environments and managing large infrastructures with the help of Terraform. This action pack provides easy-to-use actions that can create, update or delete any environment on most of the cloud platforms. Let's first start with looking at how to install the action pack. In Nolio Release Automation, all the latest action packs are available on the Action Management page, under the Administration tab. For the demo today, we have already installed the IAM Action Pack, hence it is visible under the Installed Packs section. This action pack's actions list contains: Create Infrastructure Action, Create Infrastructure Provider Action, Create Repository Action, Delete Infrastructure Action, and Update Infrastructure Action. These 5 actions allow us to completely provision an environment on a cloud platform, update it, and later if required, deprovision that environment. Now, let's talk about the Terraform file that mainly helps in creating an environment. This Terraform file contains all the details that allow us to connect with our cloud platform or the infrastructure provider instance. Here, it will take email and API key variable values from Create Infrastructure Provider Action, where we will be providing Heroku account connection details. Heroku is another cloud platform as a service based on AWS. This can be used to deploy, manage, and scale applications. The environment, which we will be provisioning today, will be named as mentioned in this file, that is, Provision VM. For our Heroku account, here we have already logged in, and we can see 2 already existing infrastructure instances that are in the sleep state. Once we execute our use case, we will be able to see our infrastructure instance here in active state. Now, let's jump to our use case that contains Infrastructure Manager actions. Here, we will start with creating the infrastructure provider instance first. Inputs contain Infrastructure Manager endpoint connection details. Provider name should be unique every time. Provider name here is the infrastructure provider instance name that will be created at the back end, and will allow us to connect with our cloud platform, that is, Heroku. Next, let's look at the Create Repository action that creates an instance or object of the repository where the Terraform file is saved. Here, the repository name is the repository instance or object name that should also be unique every time. Repository URL is the path to the Terraform file, and type is git here. The repository branch where Terraform file is committed is master, and we will next be providing repository credentials. Once the infrastructure provider and repository instances are created, we can proceed with creating our infrastructure instance. Again, the infrastructure instance name should be unique. We are providing Terraform as the backend provider. Provider instance name will be taken from output of first action in this use case. Override variable field can contain any variables that we can override in our Terraform file. So, these variables can be overwritten with values provided in this field. Next, the repository instance name is given. This is the repository folder where Terraform file is saved. Reference can be the branch, version, or tag referring to Terraform file in repository. Wait for completion can be either true or false. We can then provide initial waiting time, retry count, and interval. Also, the success or failure states of the infrastructure can be selected for success of this action. Next, let's introduce some wait using CLI command before deleting the environment. So, delete infrastructure action uses the infrastructure ID that is published as output by Create Infrastructure Action. Let us execute this workflow, and then we'll verify if the environment is provisioned or not. So, this may take some time to complete execution. Let us wait for its completion. Now, our infrastructure provider and repository instances are created and we can verify their instance IDs. Next, when the infrastructure will be created, we'll be able to see our environment provisioned on Heroku Cloud Platform. Since we have provided some initial waiting time, it will, therefore, wait for that much amount of time. Once the infrastructure is created, we can verify the infrastructure ID and its execution ID as outputs. Now, we can see our provisioned environment on Heroku Platform. As we can see, provision VM named environment is created here, and we can deploy any application on it. Let us now check the status of our workflow. So, the CLI command is inducing wait time before deleting the environment, so that we can verify our environment meanwhile. So now, the created environment will be deprovisioned. Using the infrastructure ID, it has deleted the provision VM environment from Heroku Cloud Platform. With this, we have seen how, leveraging infrastructure manager actions, we can provision an environment and later deprovision it. Thank you.